Okay, so now we're going to be discussing about Kirchhoff's voltage law, which is based on the conservation of energy. Now, recall that in the simplest form, conservation of energy just states that we can't create matter or destroy it. So what ends up happening is that energy transfers from in one form to another. In a similar situation, Kirchhoff's voltage law states that around a closed loop, we get that the sum of all voltages is equal to zero. However, I want to kind of point out that this may be misleading or rather confusing. So, what ends up happening is instead of saying this, we generally can explicitly write that the sum of all voltages dropped is equal to the sum of all voltages rise around a singular closed loop. And from here, this tells us a much better idea. This gives us a much better idea of what Kirchhoff's voltage law is really about. Now, recall that drop just means for an element, the current sees positive first. Whereas for a drop, or whereas for a rise, the current will see a negative first. So Kirchhoff's voltage law states that if we had some kind of closed loop, and let's say it had consisted of elements here, if we were to draw a singular closed loop around this, maybe assign some polarities if they're not given, then the sum of all voltages dropped should be equal to the sum of all voltages rise. So if we kind of follow the arrow, we have drop, drop, rise, rise, which states that basically then the sum of these two voltages should be equivalent to the sum of these two voltages. Now, this is where we can apply voltage polarity where appropriate and not, and under the assumption that they have not been pre-assigned. So whenever you go through the problems, most likely you're going to be dealing with resistance or resistors, and it leads to being able to find whatever information you need to find in general. A few disadvantages of Kirchhoff's voltage law is that since it's a general form of circuit analysis, it is very tedious and very, very slow. However, there are some situations that you can't really bypass it, such as in the case of dependent sources. Sometimes there are situations that really, uh, where you really need to use general circuit analysis. Now, what about another situation? Maybe perhaps you'd want to know about the differential equation that models this kind of network, what's called an RCL network or an RLC network. Well, this one's linear. These two are not so much. But with Kirchhoff's voltage law stating that the sum of all voltages is equal to zero, or that the sum of all voltages dropped is equal to the sum of all voltages rise, we can write the following. So let's assign polarity to parts that haven't already been given. We have V is equal to IR plus 1 over C, the integral of I tau d tau plus L di dt. Now, for the time being, for the viewer, This is simply the result that we get for a capacitor and for an inductor. But if the viewer has not seen the result just yet, they can safely ignore this. But notice that this models voltage, or sorry, voltage of the resistor. This models voltage of the capacitor, and this for the inductor. Notice that it's equal to the voltage rise when we sum it up and go around this closed loop like so. So that's where Kirchhoff's voltage law may be used in situations that we really can't use shortcuts. Okay, thank you. In the next video, we're going to be talking about Kirchhoff's current law, which is another form of a generalized circuit analysis. Okay,